Okay, hi guys. So again, what we're doing is we're doing multi-step for inequalities. We've done single step already, and that's just, for instance, adding, subtracting, multiplying, and dividing to the other side. So today we're just gonna practice what we did before, and we're gonna refocus, remind ourselves that if I divide or multiply across by a negative inequalities, we have to flip that inequality, okay? So here we go. So if I say 2x plus 3 is greater than 8, so we're doing inequalities. Okay, and the goal is to 1, solve for x, essentially. Solve for x. And we gotta get rid of the 2 and the 3. Which one do we get rid of first? Hopefully you guys have practiced enough that you're used to this, that we have to get rid of what's farthest away. What's farthest away here is the 3. So I'm gonna go ahead and minus 3 to both sides. Now, a rule that we went through before is that if I'm adding or subtracting across, see across this inequality here, I don't have to do anything to an inequality. It acts just like an equal sign. So 2x is greater than 5. Again, there's no change to it because we didn't multiply or divide. Only multiplication and division do we have to flip. If we multiply or divide across by a negative. Okay, and we'll see that. We'll demonstrate that. So last move, divide by 2. X is just a fraction, 5 over 2. Now, if I want to graph this, 5 over 2 is a decimal. And if we take $5 and divide by 2, you know that's $2.50, right? So X is greater than 2.5. We can graph that on a number line. Here is our 0. 2.5 is over here. Look how accurate that number line is. And is this going to be a hollow or a solid? Okay, X is greater than or equal to. It's going to be a hollow, super important to catch. And X is greater than, so this is bigger than 2.5. So bigger than 2.5 is to the right. So we draw an arrow to the right. So this problem isn't super hard. What happens is that we just want to make sure we see all the little tiny nuances. These nuances can get us if we're not paying attention. Let's do another one. This time we're going to have a negative x. 5 minus 3x is less than or equal to 4. Okay. So we decide what to get. What are we solving for? We're solving for x, and we have to get rid of the 5 and the 3. That's actually a negative 3 though, okay? That's a negative. So let's go and get rid of the 5 first. It's farthest away, minus 5 to both sides. Now, here's a big mistake. People forget to copy that negative sign, so make sure you're not one of those people. That is a negative 3x, not just a regular 3x. And we don't flip the inequality because we subtracted a negative over. That's negative 1. It's okay. That's fine. Perfectly okay. Our next step is we're going to divide by negative 3, divide by negative 3. Uh-oh, we divided by negative. That means I'm going to flip my inequality. It's or equals, so it'll stay or equals. And since the 3's and the negatives divide out, we just have x on the left side. Those divide out. We just have x. And negative divided by negative becomes a positive 1 over 3. Okay, so let's double check this answer. That makes sense. This works. 5 minus 3x less than or equal to 4. And we're going to plug back in 1/3. Hey, Let's take a look what happens to this 3 on top and 3 on bottom. They divide out. That's great. That leaves us with 5 minus 1 is less than or equal to 4. 4 is less than or equal to 4. Now, if you pick any number greater than greater than 1/3, let's pick a number. Let's say 2. Okay, 2. 2 is greater than 1/3. So if we plug in 2 here, just double check. 5 minus 3 times 2 is that going to be less than 4? 5 minus 3 times 2 is 5 minus 6. Is that less than 4? -1 is less than 4. It is. Okay, so just to double check that. If we make this problem slightly harder with x's on both sides, say 5x minus 4 is less than 7x plus 3. Now we have x's on both sides, so we want to make sure we get our x's together first. Now I'm going to do this problem in 2 different ways. I'm going to move the x's on the left, and I'm going to move the x's on the right, and see how this problem changes with our decisions. Okay, this problem will actually change based on what we decide what to do. Okay. So let's move this to the left. I don't think this is the best idea, but let's just try it. Minus 7x to both sides, because we want to combine like terms. Get those x's together, then this will become an easy problem again. 5 minus 7 is a negative 2x minus 4 is less than 3. Okay. The 4 hasn't changed and the 3 hasn't changed. So just rewriting it. But the 7s did change because we combined them to one side. Now this becomes a 2-step problem like we talked about before. So we want to solve for x, like we said before, but this time I'm going to get rid of the 4 and the 2, -2. So what's farthest away is the 4. Opposite of minus 4 is plus 4. We always do the opposite operations. And we do it to both sides, to be fair. So we're negative 2x is less than 7. And we're going to divide both sides by -2. Now be careful, remember, because of this negative sign, we divide it by negative. We have to then flip the inequality. So x is greater than now 7 over -2. Or this could be written as, put the negative in the middle. -7 over 2. So let's do the same problem. 5x minus 4 is less than 7x plus 3. And this time, I want to move the 5x over to the right. Move the 5x over to the right. So my general way of doing these problems is decide which side has more x's and move everyone to that side. Which of your friends has more fun stuff at their house? Go to their house. Don't stay at your house. It's boring. Minus 5x to both sides. See, I have more x's here. Let's move them over here. And when we do that, it gives us a cool outcome, a positive outcome that no longer is a negative 2x, but a positive 2x, which makes the problem, I feel like, a little easier. We make our decision. I need to solve for x, so I need to get rid of the 2 and the 3. We get rid of the 3 first, it's farthest away, -3 to both sides. Okay, -4 and -3 and -7. Okay, so pretty much the same exact steps. See, we did something similar to that. We got rid of the -4 there. Here, we got rid of its, like, I guess, its opposite. It's like 3 over here, its counterpart. And we end up with very similar answers. 7 and 2, 7 and 2, except the negative is on the different side now. Next step, divide by 2, divide by 2. My question here, when I divide by positive 2, do I have to flip it? So to flip if I divide by positive 2. Answer is nope. No flipping needed. So x is greater than negative 7 over 2. So if I read from right to left, isn't x on the bigger side? So x is greater than negative 7 over 2. Or you can read this, negative 7 over 2 is less than x. That's it. So let's do one more problem with division. Okay, x over, let's put negative x over 2 is less than or equal to 5. Okay, so we have a negative. So to make a decision, I need to get rid of the negative and the 2. The opposite of division is multiplication. So we're going to multiply both sides by negative 2. Why negative 2? Because not only do I want to get rid of the 2, I also want to get rid of the negative. And negative times negative is a positive. So we end up with x is less than. So let's see what happens here. The negatives cancel out, as well as the 2's cancel out, leaving me just x by itself. On the other side, we multiplied by negative 2, so we're negative 10. But I made a mistake, right? Because if I multiply or divide across by negative, you have to flip the inequality. So this is bad. And for sure, you're going to get that wrong right away. So the real answer here is x and 10, negative 10. And because we multiplied across by negative, we're going to flip that inequality. This is the right answer. Now, if you have time to check your work, you should always check your work like usual. So what I'm going to do is I'm going to test my work. Give me a number that's less than negative 10. Now be careful, on a number line, here is negative 10. So numbers less than negative 10 go this way. So we're looking at negative 11, negative 12. Now with this over here, make this a true statement. Let's go ahead and test it. If I pick an easy one, let's do negative 12. Is negative 12 over 2 less than or equal to 5? Would this be a true statement? Remember, I'm just testing it. I'm testing out my original problem. And if I negative become here, negative become a positive. 12 divided by 2 is 6. Is 6 less than or equal to 5? This is wrong. This is not true. Let's look at our right answer. X is greater than negative 10. So numbers on the right side here. So numbers on the right side would be negative 8, negative 6, even 0, right? 0 would be an answer over here. So let's just use 0, because 0 is easy. Negative x is now 0 over 2. What's 0 divided by 2? That 0 is 0 less than 5. Yeah, this is a true statement. Okay. Let's do one more as a practice, similar to this. So you can always double check your answer if you're not sure, but the big takeaway is if I multiply across or divide across by negative, you must remember, flip that inequality. So here's my last one. Negative 2 over 3x is greater than 8. So to solve this problem, I need to get rid of the 2/3. So our trick here is to multiply by what we call the reciprocal. So I'm going to multiply both sides by negative 3 over 2. Negative 3 over 2. I want you guys to visually see this, that what's a 2 divided by 2? That's 1. What's a 3 divided by 3? That's also 1. So the trick here is I'm actually doing 2 steps at once. I'm multiplying by 3 to get of divided by 3, and I'm dividing by 2 to get rid of multiply by 2. I'm doing 2 inverse operations at the same time. And we're left with x by itself because the negatives became positive. And because we multiplied across by a negative, we have to remember to flip my inequality. Now on the right side, this might be a little difficult, but you can do 2 ways. Remember, you can do top by top, which is 24. 3 times 8 is 24 over 2, which is negative 12. Or you could divide first, which I always find easier. What is 8 on top divided by 2 on bottom? 8 divided by 2 is a new 4. And 4 times the negative 3, see the negative 3 here, is negative 12. So we have negative 12. And that's it.